Hello, I'm OCD Mom. I'm usually here streaming video games with my kids, but I haven't been around in a while. I am finishing up the last classes to get my degree, and as soon as I'm done, I will be back, probably about 3 more weeks, and we'll be streaming. I promised my physics class, if we survived, that I would stream a video game for them, and it looks like they're picking Elden Ring, so I'm a little nervous, but we'll see what happens. But I will be back with some ESO, probably some Valheim, and LJ wants us to do some Dead by Daylight. Anyway, so we'll be back really soon. But as part of this last class that I'm taking, I need to do a series of math tutorials. So I hope you will bear with me as I stumble through these and try to show you a few math problems. So, I don't know. Let's get started. For those of you just joining now from the link, with the timestamp link, we are discussing the inverse of matrix from 1.4, section 1.4 in the Wiley Online Math Course. And we are specifically doing question number 3, and I'm going to attempt question number 4. Question number 3 is actually question 27 from the book. Excuse me, but they randomly generate numbers for the online course. So my numbers may vary. The process and the steps will still be the same. So we're going to find the inverse of a matrix. So the question tells us use theorem 1.4.5 to compute the inverse of the following matrix A. And we have a 2 by 2 matrix, which means we have 2 rows and 2 columns. Whoops, these are columns. These are rows. Sorry. And we need to find the inverse. Now you'll see I already have the answer here. So spoiler alert, there's the answer. But I'm going to go ahead and show you the steps on how to get that. So we start out with our matrix A, 4, 0, 0, 7, and we need to find the inverse that is written as A to the negative 1, which is not to say it's not a math. That's just a way to write this. It's not like you say 2 to the negative 1. It's a little bit different. So if we say that A is M, and if M is A, B, C, D, now it can be written as A with like a sub 1, 1 and A sub 1, 2, a sub 2, 1, and a sub 2, 2. But this is just easier to see because they're going to move around. So if we take the inverse of M, what we're going to do is you take your matrix and you flip the A and the D. So the A moves down to the D position and the D moves up to the A position. And then your B and C are both multiplied by negative 1, so they become negatives. So, and then you're going to multiply this matrix by the number that's in A times the number that's in D minus the number that's in the B position times the number that's in the C position. And when we multiply that through into the matrix, this is what you get. You'll get D over AD minus BC. So to show you what that looks like in the problem, we took our 4, which is in our A position, and we multiplied that by our 7, which is in our D position. And then we multiply it by our B position number and our C position number, which are both zeros, so they just cancel each other out. So 4 times 7 ends up being 28. So we have 1 over 28 multiplied by our original matrix, which we have flipped the A and the D, and zeros becoming negative still stay 0. So when we multiply 7 times 1 over 28 and we reduce that, we get 1/4. When we multiply 4 times 1 over 28, we reduce that down to 1 over 27. Excuse me, sorry about that. And then, bear with me here as I try and, write things. And I'm not real good. I don't have a pen, so we're gonna try and do this the best I can do. Okay, so, and then our inverse was 1/4. So this is just so you can check your work. Let's see if I can do this, write this fast enough. So what you do when you multiply your matrices is you're going to multiply 4 times 1/4. So we're going to take 4 times 1/4. Whoops, that's not a fourth. Okay, and then we're going to add that to 0 times 0, which is 0. It's not going to affect it. And then we want to take 4 times 0 and 0 times 1/7. Oops, plus 0 times 1/7. And then we're going to take 0 times 1/4. Okay, I'm sorry, this is really difficult for me to do. And 7 times 0. And then we're going to go 0 times 0 plus 7 times 1/7. Okay, so this sets up 4 sections. Individual sections that are going to be added up to give us our final matrix. So 4 times 1/4 is 1 plus 0. So we have 1. 0 times 4, 0 times anything is 0. And we have the same thing here. And then 0 times 0 is 0, plus 7 times 1/7 is 1. So what we end up with, as you will see here, we have an identity matrix. This tells us that our calculation was correct. This is how you can check to make sure that you got the correct identity matrix. The correct inverse. So if you multiply your original matrix by the inverse, you will get an identity matrix, which looks like this. An identity matrix is a matrix where the diagonal is all ones, and anything else are going to be zeros. So if you have a 3 by 3 matrix, you're going to have 1, 0, 0. And it is not a straight line. I apologize. 0, 0, 1. Wow, that is really bad. I'm sorry. But you can kind of see. The diagonal is all ones, and everything else is zeros. So don't write your math like that. Okay, so now for question number 4, we have a slightly different matrix that's a little more complicated because we don't have a whole bunch of zeros. We have 2, 1, negative 3, 4. So once again, we have a 2 by 2 matrix, which will result in a 2 by 2 identity, but we're not going to have a bunch of zeros. So you'll see here we have read the information given. Read the question first, right? Use the information given to find A. So, whoops, we are looking for A. And what we are given was the inverse of A. So this is an inverse matrix, and we need to find the matrix. Not Keanu Reeves. Sorry, bad joke. Okay, so we have our inverse, which is 2, 1, negative 3, 4. We do the same thing. We switch the A and the D, and the B and the C become negative. So see, you'll have here, we had a negative 3. We're going to add a negative. So what happens then is that becomes a positive 3, and this one, because it is positive, becomes negative. So yeah, you just multiply it by a negative. So we take our A and our D, and we multiply them together, and we take our B and our C, and we multiply them together. 2 times 4 gives us 8, minus 1 times a negative 3 gives us a negative 3. We're subtracting a negative 3, so we're basically, you add 8 plus 3 to get 1 over 11. You multiply that by each individual position of the matrix, and you end up with 4 over 11, negative 1 over 11, 3 over 11, and 2 over 11. And that would be your A. This is the A matrix. So this would be your original matrix. And we are going to prove this. 2, 1, negative 3, 4. So we're going to go 2, as soon as I switch the page, absence, and my brain, I forget every single time. You know, the old thing about the old lady walking into the next room and forgetting what she was doing? That's me. I don't think I can fit this all in here. Okay, so 4, negative 1, 2, 3. So it's flipped. All right. 4 over 11. Nope, it's not going to be big enough. Oh, gosh. 3 over 11. Negative 1 over 11. And 2 over 11. Wow, my handwriting is so sloppy. It's not even handwriting, really, is it? Right? Okay, so this one's going to get a little more complicated and probably a whole lot more messy on me. So we're going to take 2 times 4 elevenths plus 1 times 3 elevenths. And then we're going to take 2 times a negative 1 over 11 plus 1 times 2 over 11. And hopefully you're seeing what's happening here. This one is going to be a negative 3 times 4 over 11 plus 4 times 3 over 11. And this is negative 3 times negative 1 over 11 plus 1, oops, excuse me, sorry, 4 times 2 over 11. So I don't know if I explained, I just realized this, I don't know if I explained this before. When you're doing matrices, you're going to take the first row and multiply it by the first column, and then you're going to take the second row and multiply it. Well, the first row by the first column, first row by the second column, second row by the first column, second row by the second column. So that's why you're seeing a little crisscrossing of the numbers. It's kind of confusing, but with practice you get used to it. Alright, so these numbers then we end up with 8 over 11 plus 3 over 11. I'm just going to go down instead. Okay, so negative 3 times 4 is negative 12 over 11. Wow, handwriting stinks. Okay. Plus 3 times 4, and this is not a subtraction, that is a multiplication, is 12 over 11. And then we have 2 times a negative 1, so a negative 2 over 11 plus 2 over 11. 1 times 2. And then negative 3 times a negative 1 gives us 3 over 11. Uh-oh, my headphones just turned off. I hope this is recording my voice. My headphones just turned off. I apologize. Okay. 3. Sorry, that's really thrown me. Okay, so 3 plus 4 times 2 is 8 over 11. So we're going to take that matrix. 8 plus 3 over 11 ends up being 11 over 11, which reduces to 1. Negative 2 plus 2 over all over 11 equals 0. Negative 12 plus 12 over 11 ends up being 0. And 3 plus 8 over 11 is 11 over 11. 11 over 11, which reduces to 1. So once again, we have the identity matrix, which means our solution is correct. So we found the matrix, the matrix of the inverse that we were given. So anyway, that's kind of a quick tutorial on how to do inverse matrices. I hope it was helpful to you. Hope you enjoyed it, and we will see you again really soon. Thank you.